Hello everybody. In this video, let us discuss about 2024 solved EAPCET paper of laws of motion. So 9th May shift 1, the question asked is, a car is moving on circular tracked bank at an angle 45 degrees. If the maximum permissible speed of car to avoid the slipping is twice the optimum speed of car to avoid the wear and tear of tires, then coefficient of static friction between wheels of car and road he is saying. So the velocity for what he is asking, the static friction between the wheels and road, and what he give, one is the car is moving on a circular track banked at an angle 45 degrees he gave. Next what he said, maximum permissible speed of car to avoid the slipping is how it is, twice the optimum speed of the car to avoid the wear and tear of tires. Okay, so now we know the velocity formula as for banking of roads, under root rg tan theta plus mu by 1 minus mu tan theta. For optimum speed, V optimum is equal to under root Rg tan theta. Right? Here theta you substitute 45 which is given in the problem. So we get tan 45 equal to 1. So V optimum is equal to under root Rg. Now from equation 1 and equation 2 both sides squaring, we get V square maximum is equal to Rg tan theta plus mu by 1 minus mu tan theta. And from equation 2 also V square optimum we can write Rg. Now here in this equation, in place of Rg, we are substituting V square optimum. Now in place of theta, we are substituting 45 degrees. So we will get V square maximum is equal to V square optimum tan 45 plus mu by 1 minus mu tan 45. Tan 45 value 1. But in the problem, he also said that, what he said, the maximum permissible speed V maximum is twice the optimum speed he gave. Now in place of V square maximum, we are substituting this V optimum whole square, that is equal to V square optimum. Here tan 45 1 no, so 1 plus mu by 1 minus mu. V square optimum cancels. So now what we will get, for V square optimum is equal to V square optimum 1 plus mu by 1 minus mu. V square optimum cancels. 4 equal to 1 plus mu by 1 minus mu. Cross multiplication and on simplification, how we get mu equal to 3 by 5, which is nothing but 0.6. This is nothing but the coefficient of static friction. Right? Now next step, which is asked on 9th May shift 2. A 20-ton truck is traveling along a radius of curved path of radius 240 meters. If the center of gravity of truck above the ground is 2 meters and the distance between its wheel is 1.5, the maximum speed of truck with which it can travel without toppling means falling down or bending to one side and falling down. So now here, whatever he gave, first let us write. So one he said 20 ton of truck. 1 ton 1000 kg. So 20 into 10 cube kg. Now it is moving on a curved path, right, in such a way of radius some 240 meter. Right. Now distance between the wheels of car 1.5 meters. Now center of gravity above the ground h 2 meters he gave. Now first let us equate torque by gravity and torque by centrifugal force. About outer wheel we get toppling velocity. Now we have to find the toppling velocity. To do that, first we have to equate torque by gravity and torque by centrifugal force. Okay. So now here, now this is the ground. Now assume this as the car. Now the two wheels of the car. Right? Now the distance between these two wheels, let us assume as small d. Distance between these two wheels, small d. Alright? Now here, this is moving on curved road in such a way. Okay, while moving in such a way, what happens on this tire? The centrifugal force acts. So this is the normal reaction acting. Let us draw the free body diagram on this tire, and the normal reaction force will be minimum on this tire. So now if I fish, so if this is the car, it is now when turning, what happens? Now this is the curved surface. Now car is turning. What happens? It will bend in such a way, no? While turning, means the total force is acting on this tire. So N2 will be more than N1. N1 will be more than N2. Now here centrifugal force mv square by r is acting. So in such a way, so centrifugal force in such a way it is acting. Okay. So now for safe turning without any sliding, now mg acts in downwards, right, up to center of gravity. If total distance between the tires is d, up to center of gravity the distance will be d by 2. And in problem he said that the center of gravity is at height h, right. So now for safe turning without sliding, what happens? Centrifugal force will be less than mu n1 plus n2. So from that, on simplifying, we get V less than or equal to under root mu Rg. N1 plus N2, nothing but we are substituting Mg. Okay. Now next, here, for safe turning without toppling now. This is without sliding. Now without toppling. So what happened? Now car, while it is taking turn, so in such a way the car is taking turn. And when car is taking, it moves in such a way. The total force acts on this wheel compared to this wheel. This wheel moves upwards in such a way. So total centrifugal force acts on this wheel. So in this direction. Now this is h is the height of center of gravity, and a mg effect will be there, right. Now the distance from center of gravity to this wheel is d by 2. So now centrifugal force mv square by r, and height is h less than, now this force mg gravity force, this is L by 2. Now this is what we will say torque by centrifugal force. Torque formula is R cross F, no? Distance into force. Here centrifugal force, so we substituted mv square by r, and distance, the height of center of gravity h. And next what he said to balance with torque by gravity. The formula is r cross f. In place of r, the distance is here the distance is d by 2, right. The distance is d by 2, and next force is mg, gravity force. So now if we write the equation, mm strikes off, so we get v less than under root rgd by 2h. When the velocity is this much, we will not find any toppling. The safe toppling will be there. Car will not fall down. The safe toppling, and it just again turns and moves smoothly. So now what must be the V maximum for safe toppling? Under root RGD by 2H. R, the radius of curved path, right? The radius of curved path 240. D, he gave as 1.5, the distance between the two wheels. Now G he is taking to take as 10. 2 into, and height from center of gravity above earth he said 2 meters. So now that is equal to, if we simplify, we get root 900, and the root 900 value is 30. So V maximum is equal to 30 meters per second. Right. Now next, the question: an aircraft executes a horizontal loop of radius 9 km at a constant speed of 540 km per hour. The wings of aircraft are banked at angle of, we have to find this angle, and g he is saying to take as 10 meter per second square, and he gives certain options in such a way: cosec inverse 4, cot inverse 4, tan inverse 4, sec inverse 4. Let us find out which is the correct answer. What he is saying: aircraft executes horizontal loop of radius 9 km at constant speed 540 km per hour. So this is, you think as the wing of aircraft. Now, in such a way, first, so free body diagram, N, mg. Now, just what he's saying, it is executing the horizontal loop in such a way. Now, just it is moving. Now, loop came in such a way. Right? Now, the radius of loop, how much he said? 9 kilometer. The radius of loop he said as 9 kilometer. Now, free body diagram, let us draw. Mg will act in downward direction. Centripetal force, or sorry, centrifugal force will act in this direction. Okay. Now, this is N. Resolve N into two components. One along it n cos theta, other perpendicular to it n sin theta. Right? Now, radius 9 kilometer means 9 into kilo means 1000, 10 cube meter. Speed 540 kilometer per hour. We are converting kilometer per hour into meter per second. Kilo means 1000. 1 hour is equal to 3600 seconds. So, simplifying this, we get 150 meters per second. Right? So, now he is asking to find the angle theta. He is saying to take G as 10 meter per second square. Right? Now, from the diagram, we are clear that n cos theta equal to mg, f is equal to n sin theta. Right? Now, let us write n cos theta is equal to mg, n sin theta is nothing but centrifugal force mv square by r. Okay? mv square by r. Now, divide 2 by 1. So, n sin theta divided by n cos theta equal to mv square by r by mg. mm strikes off. So, sin by cos tan theta. N also strikes off. Here what remained? V square by Rg. Now all he gave V as 150 whole square by R 9 kilometer, that is 9 into 10 cube, into G he is saying to take as 10. So now if we simplify, we get 1 by 4. Okay, if we simplify, we get 1 by 4. Now 1 by tan theta equal to 4. 1 by tan theta is nothing but equivalent to cot theta, that is equal to 4. Now theta is equal to, what is the answer? Option B, cot inverse 4. This is the answer. Right? Now the next question which he asked in 10th May shift 2, that is, now before 10th May shift 1. Now a block is kept on a rough horizontal surface in such a way. This is the rough horizontal surface. We kept a block. First we applied 20 Newton of force. Acceleration is 6 meter per second square. Next we applied 30 newtons. Acceleration increases to 11 meter per second square. Now to this force in opposite direction frictional force is acting. Right? Now he is asking to find the coefficient of friction between the block and the surface. So now let us analyze these two diagrams. Now a block we kept on the surface for 20 Newton of force. 6 meter per second square is the acceleration and this is the frictional force. Now net force, how we will write? Large force minus frictional force. So large force is 20 Newton minus frictional force is equal to the net force MA. Now M he didn't give, so A he gave as 6 meter per second square. So substitute M into 6. Similarly here also, so 30 minus F is equal to M into 11 meter per second square. Now let us solve. 30 minus F is equal to 11M, 20 minus F equal to 6M. Here M is nothing but the mass. Right? Now minus plus minus, F cancels. So 30 minus 20, 10, 11 minus 6, 5 into M. So from this the mass is equal to 10 by 5. That is equal to 2 kg. So mass we got it as 2 kg. Now this 2 kg you substitute here. 6 2s are 12. So F becomes 20 minus 12, that is equal to 8 newtons we got. So one we got the value of frictional force as well as mass. Now what is the formula for? What he is asking? The coefficient of kinetic friction. The formula for frictional force is mu Kn, where N is the normal force which is equivalent to mg. Right? Which is equivalent to mg. So from here N the normal force and mg. So only N equal to mg. Right? N equal to mg. So now mu k he said to find. So F by mg. F8 we derived. next M as 2 and G he is saying to take as 10. So we will get answer as 0.4. Okay, the option C is the correct option. Now next, so 11th May shift 1. A block of mass 5 kg is kept on smooth horizontal surface. A horizontal stream. Now what he is saying, here I will draw the diagram. A block of mass 5 kg is placed on smooth horizontal surface. A block of mass 5 kg. Right? A horizontal stream of water coming out of pipe. Here one pipe is there. And pipe is of area, he is saying 5 centimeters square. Now, the stream of water, horizontal stream of water with velocity of 5 meter per second. Horizontal stream of water with velocity of 5 meter per second is hitting the block. Is hitting the block. Right? Now next, again this water rebounds with the same velocity of 5 meter per second. Right? Now when it hits this block, what happened? The blocks will move no, to certain distance. Again this water is, again it is rebacking. Now what he is saying? He is saying to find the initial acceleration of block. When it hits, the block moves to somewhat no. So now he is asking to find the initial acceleration. So given the area of cross section of pipe 5 centimeter square. So converting into meter square, 5 into 10 to the power of minus 4. Now velocity of water he gave as 5 meter per second, and the density of water we know 1 gram per centimeter cube. So that is nothing but 1000 kg per meter cube. Right? Now mass of block he gave as 5 kg. Now the mass of flow rate, we will write it as dm by dt equal to rho a v, where v is the velocity. V is the velocity. Now how we got this formula means density is equal to mass by volume. So mass is equal to density into volume. Volume is equal to, we can write it as area into distance. Right? Area into distance. Now divide by dt on both sides. Dx by dt is nothing but the velocity. In such a way we got dm by dt, the rate of flow of mass, rho a v. Now the density of water 1000, area of cross section 5, 5 into 10 to the power of minus 4, we converted into meter square, and the velocity 5 meter per second. Now multiplying this, we get 2.5 kg per second, right? Dm by dt we got. Now next, the water hits the block and rebounds, he is saying. So water hits the block and again it rebounds, but in opposite direction, or in this direction it is hitting, in this direction it is rebounding. Right? So now the change in velocity, how we will write? V final minus V initial we write. So V final, both with the same velocity he said in the problem. Again rebounding with the same velocity he said, but same velocity, okay. Now this becomes the V final and this becomes the V initial with the same velocity but in opposite direction, no. So we will write minus 5. And minus of, as usual, initial velocity is also 5. So we will get minus 10. Right? The change in velocity we are getting minus 10 meter per second. Now the force exerted by water stream, we are using the rate of change of linear momentum. The force is directly proportional to the rate of change of linear momentum delta p by delta t, where p is the linear momentum and p is linear momentum means mass into velocity. So mass into change in velocity. So dm by dt we already find it as 2.5 and velocity change minus 10. So answer will be minus 25 Newton. But here negative sign indicates the direction of force, but we need only magnitude. So we are neglecting this negative sign and taking F as 25 Newtons. From Newton's second law, F equal to ma. What he said, the acceleration when we hit the block with the water, the block moves or accelerates. Force is applied with respect to the water, with the help of water. We are hitting with the water means force is applied on the block. Force is applied on the block means block gains the acceleration. So such acceleration is F by m, where F is 25, m mass he gave in the problem as 5 kg. So from that we get A is equal to 5 meter per second square is the acceleration of the block. So these are the questions asked in 2024 on laws of motion. So keep watching my channel. If you like my video, share it, subscribe it. Thank you.